with the recording, it will be posted on the YouTube sites, on the SBS YouTube site, as well as it will be posted on the SDS Consortium website. What we're going to be talking about today is the bus and cable. Just a couple things that I've noticed in some help questions I've gotten that people forget there's other tools than PIC fittings. So we're going to look at that. We're going to look at a little bit of the utility content. I wanted to show a little bit more, but you know, things don't always work out perfectly. I'm going to show something on the Utility Data Hub. There is a handout. I put it in the handout on the Utility Data Hub if you want to take a look at it. It's a software that we can compare our SDS, PNC 2D schematics and compare the accuracy of that with the 3D model and vice versa. And that can help us with our design checks. I'll take Q&A at the end of the talk. And if I have time, I'm going to show you something on creating circuit breakers. All right. So I'm going to start with the first one is on fittings, and that's what we're going to be talking about today. So let's come into my model here. I have a model, and what I'm going to do is just place a couple fittings. And often what we look at when we're placing, I shouldn't say placing fittings, placing cables, bus. That's what I'm talking about. I'm sorry. Cables and bus we're talking about. If we look at our cables and bus, we have a number of things here, PIC points, PIC cylindrical surfaces. That's one that I think gets commonly forgotten in when I've been working with people in the last month or so, or even longer, people forget these type of tools. So if I take this group of fittings here and I have it set up, I can just run and I can grab pick fittings to add cables. So I can pick multiple fittings. So I'm going to pick this guy, and this guy. And I'll hit enter. And my fitting goes through. So it looks nice. It's all through. And I had to set it up so that I could do this, right? There's some orientation issues with fittings, but I had to make sure I had the orientations correct. But if I didn't have the orientations correct and I was being frustrated or whatnot, and I didn't want to do it that way, I want to make sure we're aware of pick cylindrical surfaces. So let's pick the cylindrical surfaces. I want this surface to this surface, this one to this one, and this one to this one. So what I'm seeing here is multiple ways of placing this cable. Now, when I pick a cylindrical surface, it's going to end right on the edge of the cylindrical surface. It's not going to extend, but I think that's fine for what we're doing here. If I were to delete that again, I wanted to put a sag in there. So let's do that with a sag. So let's put our sag in there. 8% sag is a lot for this type of cable. Tons actually, but we'll put it in. So we'll put that piece in again. I did save it, didn't I? Sag, yeah. So we have it in here. So it looks nice even with the sag. So just want to show you that cylindrical surfaces works well. I'm going to show it again later on. But the next thing I want to do is look at a little bit of a bus. So let's look at what we can do with the bus, cylindrical surface again, and other PIC things. So let's look at our bus. I'm going to leave the bus settings as is. And I'm going to pick my bus fittings. Pick fittings to add bus. So I want this fitting, and this fitting. All right, so now I have my piece of bus in here. I could also use pick cylindrical surfaces for this as well. If I were to pick the cylindrical surface here, here, and here, it would work as well. What I want to do as well is I have a sphere here. So I'm going to place a bus to the sphere, I got a sphere coming up here, so they're not in line at all. And that's what we're going to do here. So I'm going to put this sphere here at 2.5 and an eighth. So if I come in here, take my settings, 2.5, and this one I want as an eighth. And I'll hit save. And I can pick my two fittings. I'm going to pick this fitting to this fitting. And there's my piece of bus, right? So if I come in here and delete that run, put negative signs in there, it might be a little bit better. So let's look at that bus with negative signs. Negative signs, save. Let's put that bus in there again. All right. If I didn't like that one, we can go the other way. Okay. So I can get that offset to the point where I want it connecting to the fitting. And I see I put the wrong numbers in, so let's get the right numbers in. I don't want to spend too much time on this. 0.1 and negative 0.1875. Pick fittings. All right. So we have our piece in here. So what I want to do is get my bus coming from one ball to the next ball. And these are the spheres. So what I have is I'm going to come in here. I'm going to change my settings to negative 3.875. It's just the spacing of the bus. And I need to have inch in here. If I forget inch, I think we all know this. I think in training I say this repeatedly and I forget myself. And I can come down here and pick cylindrical surfaces. So I'm going to pick, I don't see the cylindrical surface in here, but we know because these bus balls are hollow and they have the hole in them. So I want to pick my cylindrical surface here. And with that, I have my bus going in two different directions. If you look at it, it's a height as well as an X direction as well. So now I can just place my last piece of bus in here, and that's going to be something like 875 and 1. So let's make sure I put my inches in here. And hit save. And we should be able to pick our two fittings here to finish this bus. Right? So that's placing the bus in there. Now I had a couple people coming up and saying, not coming up to me, emailing me. Kind of hard for them to come up to me. The other thing is placing a dampener cable inside. So if I come in and pick cylindrical surfaces again, to pick dampening cable inside, I can pick this surface here. I can pick this surface. I can pick a surface in cylindrical surface in here. I should be able to pick this one. And we should be able to pick that one. Let's see that way it works in there. And with that, I have a cable in there. Now it's sticking out because I didn't start it correctly. So we can delete that and delete that. And we'll do that again. Let's change that cable to a 0 sag, because I don't want it to sag inside because I want it accurate. And let's pick surfaces again. Let's pick this guy, this guy, this guy, this guy, and this guy. And now I'm going to have my cable on the inside. You can see it stemming out there. It always ends on the edge of the surface on cables. And if I change my view, where's my view? You can see the cable is on the inside. So you can use that as a dampening cable. So it can go on any type of direction or whatever. Now you wouldn't use a dampening cable like this, of course, but this is for example. So again, if we went into below grade tools, and we're still thinking of that same type of thing, of cylindrical surfaces, I'm going to put my piece of conduit here. And if I want a piece of cable in that conduit, I would be doing the same thing. I'll be picking the surface, cylindrical, cylindrical, cylindrical. And I want to end on this one. And with that, I have the cable on the inside and cable on the inside there. So that's just placing cylindrical surfaces is a great tool for adding additional things. We can do that. We can just select cylindrical surfaces for putting a vertical piece in here. We can put cylindrical surface for putting dampener cable on the inside, cylindrical surface for the spheres, for connecting our spheres, and of course for cable as well. So with that, I'm going to leave that. The other question I had was circuit breakers. I'm going to bring up circuit breakers. I think it's worthwhile to show just because of the questions I've been getting. And I'm going to go back over this. And here's a circuit breaker I built recently. And I'll show you why I built it. Maybe we'll go there first. I'll show you why I built this circuit breaker. I had a customer, and they had built a circuit breaker, and we looked at it, and I wanted to change it, so I built a new one. And I'll show you why I wanted to change it. The one in blue is the one that somebody else had built, and they didn't build it accurately. What they actually did was try and move and shape it using the, I don't know, the design tools or something like that in Inventor, whereas the 3D model tools, move, change, and stuff like that inside the tools here. And I just don't see doing that you're going to get something accurate. So that's why I built a new circuit breaker. You can see in the baby blue, the cyan color is what the other people built, and this is what I put together. So if we're doing phase-to-phase clearances, phase-to-ground clearances, I think that's a significant change. I'm not too worried about the structure as long as the footing is done accurately. And even if the cabinet's a little bit off, it's not a big deal. But I think it's a big deal on the fittings. So when I looked at that, I thought, well, maybe people need to see how to build a circuit breaker if that's what they're going to be doing. If you're going to build a circuit breaker and you think, well, it's a lot of work and it's lost time, it's not lost time because you'll have it forever. Once you have a circuit breaker, you can change it forever. Like you have it for whatever you want to do. If you want to build another similar one, if you want to change something on it, you have it easy to do. So the idea when we talk about Vault, we talk about putting items in Vault and running it that way. I would put this whole assembly in Vault. And what I have done is coming up in here. Let's look at, that's not the one I want. I would put in Vault the whole assembly in the Vault as well as the data sheets I use to make them. So I'm going to use this data sheet to make my circuit breaker. Right? So that's where I'm modeling it from. When I'm making my circuit breaker, I'm going to use the Inventor tools that I have. I am going to create everything in pieces so that's easy to assemble and easy to make and be accurate. I'm also going to use frame generator. When you take the training, I talk about frame generator, and those who have taken the training would recognize this type of shape for my frame generator. So it's this type of thing. If I had a different height on this, it would be driven from that frame generator. If I needed to make a new one, I would use copy design from Vault and make a new one. If I was to make this one, I would also create a drawing of it and leave it in the Vault as well to show that I've looked at the dimensions and they're accurate. And I might even copy and paste something in here to tell me what it is. This is what I typically do. It's an accurate result, and it's a good result. Then you would shrink wrap it, and then you would take that shrink wrap and use it in your project. But I would leave this in a templated assembly. So that's just an example. If you go into the bushings, you can see how it's broken up. I'm not trying to make one big piece. You can see how many pieces there are in here. It's easier, a lot easier if you have a lot of different pieces, right? And then you assemble it and you can be as accurate as you want to be. So the key thing there is I wanted something to be accurate. I want it saved, and I've been doing it in this method for quite a long time. It's not something new by any means. The other thing I wanted to look at is Utility Data Hub a little bit. Where are we opening? There we are. So when we come into Utility Data Hub, we can download files directly, models, but we can also download configured models too. So this is where we're at now. We're still building this. It's not final by any means. Now I don't want a circuit switcher. I want a disconnect switch. So what we're getting here, we have a disconnect switch. I'm going to let it load. And here it is here. And what I'm finding now with the 3D, with this configurator 360, it's not behaving exactly the same as what it does in Inventor. I'm not getting the updates, even though the iLogic behind this is driving the updates. As you can see, I can add Arcorn, and I can add an open path. It's not getting the updates. It runs fine with the in Inventor, so we have to rerun it to get the everything to run properly. There we go. So it looks good there. So what we do then is we can download it as a STEP or a SAT. I'd stay away from the 3D DWF, but the STEP or SAT you can download. So once you download that, you can do something with it. So we're having a little bit of trouble here with the updates, with the iLogic updating the model, but we'll get through there. We're still in trials and still working through it. Still in beta mode, you would say. Now, as a SAT file or a STEP file, if I import this item into my model, Inventor does not give you a choice of what template to use. So you're best to choose your template and then bring it in. So I'm going to come up to New, and those who have gone on the Substation Design website know there's templates that we recommend to use, or you can create your own, but we would recommend ours and then create your own from ours if that's what you wanted. But I would open up our template. The reason being is that home is with the consistent Z vertical and in this orientation. And then if you took in that SAT, and this would work with any type of SAT or STEP file, if you brought in and you come into import right here, you can import that SAT file. So let's find out where that SAT file was. So I got a STEP and a SAT file. I'm going to bring in the STEP file. You notice I'm picking all models of file type. I can open that up, and it gives me a lot of choices on how I want that brought in. Right? Multi-body part. You want multi-body part for design checks. You want it multi-body part. You can select different items that you want loaded on, but really you want them all loaded on, and I'm going to say OK. So once it's in, right now where we're at, what we would do is take it and we would convert it so we can do substation design checking. We would suppress the pieces. If you read the document on substation design, design checking, you'll see what we need to do for that. If we come into switch open, the reason I have switch open here is some people are asking for this type of proximity switch. So I would leave this on. This is the idea on how you would work this, and you would add a parameter for that. If I come up here and add a parameter, open close type of parameter in here, and this is in the documentation we have. We want it unitless. If you look at the design check document, you'll see that this method is in there. And then we can come in and put that on a switch for if open and close equals 0. I want it suppressed, right? So now if I turn this to 0, it will suppress. So it's that type of thing, and you can drive that. That is very similar to the suppression of the design checking tool, and you can use that in here as well. So if we came in here and did a view and come up to our model editor, we can come in and we can do what we normally do for design check in the model editor. It's a disconnect switch. I want to call it something. You always need to name it something. You need at least a minimum voltage in here if you're going to do this fully. We want to add local location points. So I'm going to add a hinge side is going to be down here. And a latch side is here. Let's put that hinge side on again. It didn't look like it took. So we show terminals. High terminals. And notice I picked on the outside edge. That would be recommended. And this information is saved within the file. And if I come into clearance check, this is where I can toggle items on and off. I can come in here and select my part. And it was working earlier. And even if it didn't work the way I wanted it to work, we'll see. No. You can always add the properties in here if clearance check equals 1, right? Then we can turn that on and off, and that's what we need for design checking. So I just wanted to go over that as well. So when you're bringing in your model, your SAT files, SAT files, STEP files, it is best to bring it in from the Manage toolbar with your Inventor template open for SDS template open, and bring it in this manner. And that way you get the orientation set. If you bring it in the import right from file open, you will not get the orientation, and you may want other information in that part when you bring it in. It could be company name you want or whatnot. So I'm going to leave that as that. So we did a couple things. We used circular picking for cables as well as bus. We looked at how to make a circuit breaker, how to import a STEP or SAT file, especially from utility content. The last thing I want to talk is about the UDH. And then after that, we'll take questions. So I have a little video on the UDH that I want to bring up. I'm going to come up Tools and More, and I'm going to open up my UDH tool video. So what the UDH does, it, like I said earlier, it compares your schematic 2D, your schematic 3-line 2D drawing with your Inventor model, and this is where we compare things. So I'm going to run this for a bit, and I'll talk for a bit and run it for a bit. One thing I should mention is in the handouts is a handout on this documentation. It's not this video, but there's some documentation there. I'm still working on some documentation for it. I'm sure be formalized, could be formalized by another team, but I needed something for myself, so I thought I'd share it. So the Utility Data Hub does a lot more than what we're doing here. We're only looking at Utility Data Hub with SDS. We're not looking at the whole shebang for Utility Data Hub because it works in the SQL area of the world, of the substation. And once you're manipulating data in SQL, you can do almost anything. And we're just looking at the SDS world here. So the UDH can use the same SQL as your document management tool uses. So right now I have a SQL running off of Vault Basic, and I'm able to run it from that SQL. I don't need Vault to run it. I just need the SQL. So I'm going to come back into play. So on the AutoCAD E side, on the AutoCAD electrical side, what we need to do is identify certain aspects in the attributes. We need a tag and an auto match. We need two things for us to match the breaker or the transformer or the switch or the device in the schematic with two tags that are or iProperties in the model. And that's the way we're going to match these things. So if we want to match it, we want a tag, and that's the tag 1 is going to be matching that item. If we don't want it to match, we would have the UDH auto match tag empty, and then it will ignore that device. All right. I want to stress that the attribute names can be configurable. You don't need to use tag 1 in UDH auto match. This is just for this example, and you can change it. We need the block terminals identified. We need the information in here. The wires must be terminated. You can see tag 1 is CB10, UD auto match is tag 1. So we're going to go from there. So in here, now we're going to prepare this part so that we make sure that we can use this as a UDH tool to do the match. And here we can see the part. We have the information here. You can see all the terminals that are all mated up in the phases. This in the transformer as well. You can see T1. You can see all the terminals for the transmitters in there as well. And with that, it's ready for the Data Hub. And the Data Hub is accessible directly from the current CAD tool. In the Inventor world, it's a similar thing. We need to have iProperty names that are configurable, tag 1 in UDH auto match. What we also need to do is model the terminal points, kind of like what we did in the switch earlier. Well, it is the same thing as the switch earlier, as well as we have to add these terminal points in here as well. And notice I'm picking up at the top of the terminal points, not at the bottom. The phases must be selected. This is how the UDH is going to understand where the phasing is in the model, if you phase A, B, and C. So this is how it's going to do with the SDS design check tool. In the AutoCAD, you have a number or a letter you put right on it, and that's the way we do it. So here's a circuit breaker. Here's the custom. In this case, they use different names, switch number and equipment class, but it's the same thing. As I said, those names can be configurable. So in a model, we can see that we're showing the A, B, and C phase, and this is how we identify those phases, and then we identify the terminals. All right, so now we're going to run this. I'm just showing it. This is what we're using the design check tool to identify it. So we're going to run it. We're going to have a project file, the project file. We're going to have the phases identified. We turn on the UDH Data Hub. It's available in both softwares, AutoCAD E and Inventor, but it can be run standalone as well. So here's the project file. It's going into the database to get this information. So you need some database work to set it up, but once it's set up, it's very easy. I need to create a data set to save it. You can see I have 2 Inventor data sets and an ACAD-E data set. So you can have a history of data sets in there to compare. I can compare several revisions of ACAD-E with several revisions of Inventor. You can see I matched the items, so we know what items are matching because we have that matching iProperty or attribute. I'm going to run some tools, and the 2 tools I ran here was breaker rotation and transformer. And I'm going to just pause it here in a second. And you can see here that it's saying the data match did not match on this one. It's saying that terminal 3 on Inventor is attached to terminal 1 in the ACAD-E. So what that means is we have to find out why is that going on. Did we do the schematic wrong? Is Inventor wrong? Or is it something else? So we have to go through there. On the CB10 here, everything matches and it looks good. So we're flagging something's not matching. Here on the transformer side, everything looks good. H3, X3, it's all matching up. 3 to 3 Inventors, it's all matching. So the transformer is good. We have questionable on 1 circuit breaker. Here I'm just saying you can run it independently because it's just in SQL. So here we're accessing the database with the tool. We don't have Inventor or AutoCAD-E installed, and we're running it on its own. Here's a list of the many design checks you can do, and here's a replication of the results. So that's the UDH with STS, and again, I'm just showing it with STS and nothing more than that. So there's a number of things we looked at there. I'm going to leave it open for questions. It's 12:36. If we're done early, Merry Christmas to everyone. And we'll leave it at that. And if you guys have questions, let me know and bring them out. And I'll pause for there. If anyone wants to visit something else we looked at, we can do that as well. Like I said, there's a handout available. Would you recommend, this is from Stephen, would you recommend using above grade tools cable over below grade tools for cable in the conduit? It depends on what you're doing, and I think that's a really good question. It doesn't matter as far as the cable on, there's no intelligence to the cable if it's in below grade tools. So you can do it either way. The nice thing with the using cylindrical surfaces for the cable, sometimes it's a little bit easier than the below grade tools, but the below grade tools allows you to map it out a little bit faster. So it's going to be a decision on your end on which way you're going to do.